Our song today is We Built This City by Starship. So we've got linear functions and function notation, a lot of information in this video. We're going to be able to evaluate function notation and write linear functions and use them to solve problems. So of course, vocab, remember to turn to your vocab section, you should have kept a couple of pages for that. Function notation, what this does is it replaces the y value with f of x, and this tends to be confusing for students, and it doesn't need to be if you understand the pieces of the function notation. First of all, the first piece, the f on the outside, is just the name of the function, and you can name the function anything you want to. You could have smiley face of x if you wanted to, or question mark of x. Typically, of course, to make it a little less confusing, we use letters of the alphabet. F is the most common one because F is for function and it's function notation. But you'll also see a lot of G's and H's, the letters right around F. F of x, the entire expression f of x is the value or the output of the function. Remember, f of x replaces y, so the f of x quantity is your y value. And that means it was evaluated for a specific input, x value. We're also going to be taking a look at point-slope form of a line. If you have seen point-slope form before, you probably saw it expressed a little bit differently than this. I like this modification of point-slope form because we can use our asylum analogy. Hopefully we had a chance to talk about that in class yesterday. If not, we will for sure start off class talking about what I mean by an asylum. So the parentheses are our asylum. So inside the asylum, it's not normal. It doesn't do what you think it should do. So it looks like a negative x1, but it's really positive. Outside our asylum, we have a plus y1. It's outside the asylum, so it's normal, so it really is positive. Then we have some different names for the x and the y value. The independent variable, or the input, or the domain. And the dependent variable is your y value, or your output, or your range. All right, first example, we're just going to straightforward evaluate some function notation. So here's how we do that. For x equals 5. So we are going to take this 5, replace all of the x's with 5. So now we have g of 5. So the g function evaluated at the value of 5 equals 3 times 5 squared plus 4 times 5 minus 1. So everywhere we see an x, we replace it with a 5. And then we evaluate. So we get 3 times 25 plus 20 minus 1. 75 plus 20 is 95. Minus 1 gives us 94. So the value of the g function at the x value of 5 is equal to 94. So if we wanted to write this as an ordered pair, x value, y value. Next one, we're going to write an equation given a slope and a point. This is why I really like the point-slope form of a line, and then it's very easy to translate it into slope-intercept, which is that common form because it's unique. The point-slope form is not a unique equation because you could just change the point. There's lots of points on a line. So we're going to be practicing our function notation. So it might be helpful to translate this into a regular point. Our x value is 12. Our y value is 3. Over here, our x value is 3. Our y value is 4. So given 2 points, in order to write an equation, I need the slope. So we've got our slope formula, change in y over change in x. The key here is making sure that whatever y value you start with in the numerator, you start with the corresponding x value in the denominator. So we get negative 7, negative 9, or 7/9 for our slope. And then I can choose either point I want to. Neither one of them is real helpful with that 9 in my denominator when I want to change that to slope-intercept. So I'm just going to go ahead and use my first point because the numbers are a little bit smaller. So point-slope generically looked like this. So remembering our asylum analogy, when I substitute, my slope is straightforward. My x-coordinate, remember I'm using the second one, my x-coordinate is a positive 3, but it's going in the asylum, so it's going to do the opposite of what we think. and my y value is outside the asylum, so it's normal. It really is negative. So to put this into slope-intercept form, I think we've had this on before too. Distributing, I'm going to get negative 21/9. And actually, I should have simplified that instead of simply multiplying. So 3 goes into 9 3 times. I've got 7/3. And I'm going to convert my integer to a fraction with a common denominator. So I'm going to multiply by 3/3 so that I can combine my like terms. So I get 7 times x minus 19/3.